you ever laid on your back on a clear dark night? Far away from the bright lights of the city, the sky comes alive. It is a breathtaking sight. Thousands upon thousands of stars sparkle like tiny diamonds scattered across a vast black velvet cloth. As you gaze upwards, questions may begin to bubble up inside you. Where did all of this come from? How did these stars, these planets, and our own world come to be? You might notice patterns, like the familiar shape of the Big Dipper, or the soft milky glow of our galaxy stretching across the heavens. It all seems so grand, so orderly, and yet filled with a deep and profound mystery that has captivated humanity for millennia. This sense of wonder is not limited to the stars above. It is right here with us, on our own planet. Think of the intricate patterns on a butterfly's wing, each one a masterpiece of color and symmetry. Consider the complex dance of a bee, communicating the exact location of nectar-filled flowers to its hive mates. Look closely at the delicate structure of a snowflake, where no two are ever exactly alike, yet all follow a beautiful six-sided design. From the smallest insect to the largest whale, life is teeming with examples of astonishing complexity and seemingly purposeful arrangement. It is a world that invites us to look closer, to ask questions, and to marvel at its ingenuity. This feeling of awe is the starting point for a great journey of discovery. It is the same feeling that has driven scientists, philosophers, and explorers throughout history. They looked at the world around them and saw more than just random occurrences. They saw systems working together, parts fitting perfectly to perform a function, and an underlying order that seemed too precise to be a mere accident. This observation of order and complexity in nature is what leads us to one of the most fascinating ideas in modern science: the theory of intelligent design. It is a journey that asks us to consider whether the universe and the life within it are the products of chance, or if they bear the hallmarks of a guiding intelligence. As we stand under that canopy of stars, we are not just looking at distant points of light. We are looking back in time, at the history of the cosmos. We are also looking at the very elements that make up our own bodies, forged in the hearts of those ancient stars. This deep connection between ourselves and the universe prompts us to think about our own origins. How did life, in all its vibrant diversity, arise from the simple matter of the early universe? Was it an unguided, random process, or does the evidence point toward a different kind of explanation? This quest for answers is at the very heart of what it means to be human, and it is a quest we shall embark on together. So what exactly is intelligent design? It is an idea that proposes that certain features of the universe and of living things are best explained by an intelligent cause, not an undirected process such as natural selection. Think of it like being an archaeologist. When an archaeologist uncovers a piece of pottery or an arrowhead, they immediately recognize it as something made by a thinking being. They do not assume it was formed by wind and rain. Why? Because the object shows signs of purpose and deliberate creation. Intelligent design applies this same kind of reasoning to the natural world, suggesting that some things in nature also show clear signs of being designed. It is very important to understand what intelligent design is not. It is not the same as religious creationism. Creationism typically starts with a specific religious text, such as the Book of Genesis in the Bible, and interprets scientific evidence through the lens of that text. It often makes claims about the age of the earth or the identity of the creator. Intelligent design, on the other hand, does not start with a religious book. It starts with the evidence found in nature itself. It follows the evidence wherever it leads, without making claims about who or what the designer might be. It is a scientific inquiry focused purely on detecting the presence of design. The core of intelligent design is simply about observation and inference. Scientists who support this idea look at the biological and cosmological data we have collected and ask a simple question: what is the best explanation for what we see? They argue that when we observe systems that are incredibly complex and contain specific functional information, the most logical conclusion is that they were designed. This is a common type of scientific reasoning used in many fields. Forensic scientists, for example, infer a deliberate act when they find evidence that could not have occurred by chance. Intelligent design applies this same logic to the patterns we find in the natural world. Therefore, intelligent design is presented as a scientific alternative to the prevailing view that all of life and the universe arose through purely natural, unguided forces. It challenges us to consider all possibilities and to not rule out design just because it might have philosophical implications. It encourages a more open approach to scientific investigation, one that is willing to explore hypotheses that might lead beyond the standard materialistic framework. It is a theory based on the observable facts of nature, seeking to explain the intricate and purposeful structures we find all around us, from the tiniest cell to the vastness of the cosmos. To understand intelligent design more deeply, we must explore its key concepts. These are the tools that scientists use to identify whether something in nature might be the product of a mind. The first of these powerful ideas is called specified complexity. Something is complex if it is very unlikely to have occurred by random chance. But complexity alone is not enough. A random string of letters like WKL's JDHF NCBV is complex, but it means nothing. For it to be specified, it must also match an independent, meaningful pattern. The phrase "an intelligent cause," for example, is both complex and specified. It is a specific functional sequence of letters that conveys a clear message. This brings us to the second key concept, irreducible complexity. Imagine a simple, old-fashioned mousetrap. It is made of several parts: a wooden platform, a spring, a hammer, a holding bar, and a catch to hold the bait. If you remove any one of these parts, the mousetrap will not just work less well, it will not work at all. It is irreducibly complex because all its components must be present simultaneously for it to function. Proponents of intelligent design argue that we find many such systems in biology. They are like molecular machines where the removal of a single part causes the entire system to fail, making it difficult to imagine how they could have evolved step by step through a gradual process. The third major idea is known as fine-tuning. This concept moves our view from the biological world to the vast scale of the entire universe. Scientists have discovered that the fundamental constants and quantities of physics, things like the strength of gravity, the mass of an electron, or the expansion rate of the universe, are set at values that are exquisitely precise. If any of these values were changed by even a tiny fraction, the universe as we know it could not exist. Stars would not form, planets would not hold together, and the chemical building blocks of life would be impossible. The universe appears to be finely tuned for the existence of life. Together, these three ideas, specified complexity, irreducible complexity, and fine-tuning, form the foundation for the argument for intelligent design. They provide a framework for detecting design in the natural world. When we find systems that are not only highly improbable or complex, but also match a functional pattern or are specified, or systems that require all their parts to function or are irreducibly complex, or a universe whose physical laws are balanced on a knife's edge to permit life or are fine-tuned, we are justified in considering an intelligent cause as the best explanation. These concepts invite us to look at the world with new eyes, searching for these telltale signs of purpose and ingenuity. Now, let us see how these ideas apply to the living world. One of the most famous examples used in discussions of intelligent design is the bacterial flagellum. This is a tiny, whip-like tail that some bacteria use to swim. When we look at it up close with powerful microscopes, we find that it is not a simple tail at all. It is a marvel of microscopic engineering. The flagellum is a rotary motor, complete with a propeller, a drive shaft, U-joints, bushings, and a stator. It is made of about 40 different protein parts, all working in perfect harmony, spinning at incredible speeds to propel the bacterium through liquid. It is a true nanomachine. This structure is a prime example of irreducible complexity. Just like our mousetrap, if you were to remove one of its essential protein components, such as the drive shaft or the propeller, the entire motor would cease to function. It cannot be built gradually, step by step, because the intermediate versions would be useless and would offer no survival advantage. The flagellum only works when all its parts are assembled and in the right place. Proponents of intelligent design argue that it is highly improbable for such a complex, coordinated machine to arise through a series of random mutations and natural selection. It looks for all the world like a machine that was designed for a purpose. Another powerful example lies within the very core of life itself, our DNA. Deoxyribonucleic acid, or DNA, is the molecule that carries the genetic instructions for the development, functioning, growth, and reproduction of all known organisms. What is truly astonishing about DNA is that it is a digital information storage system. The structure of DNA is a long sequence of 4 chemical bases, often represented by the letters A, T, C, and G. The specific arrangement of these letters forms a code, a set of instructions that tells the cell's machinery how to build all the proteins necessary for life. This is a clear case of specified complexity. The information in DNA is not just a random sequence of chemicals. It is a highly specific and complex language that directs the construction of life's machinery. The amount of information packed into a tiny cell is staggering. A single human cell contains a digital code that is over 3 billion letters long. If you were to print it all out in books, it would fill a library of thousands of volumes. The origin of this complex, specified information is one of the greatest mysteries in science. Intelligent design suggests that information is a hallmark of a mind, and that the sophisticated code found in DNA points directly to an intelligent source. The evidence for design is not confined to biology. When we turn our gaze outward to the cosmos, we find an equally compelling story. The laws of physics that govern our universe appear to be extraordinarily fine-tuned to allow for the existence of complex life. Scientists have identified dozens of these universal constants and quantities. For instance, the force of gravity has a very specific strength. If it were slightly stronger, stars would burn too hot and too quickly for life to develop on any orbiting planets. If it were slightly weaker, stars and planets might never have formed at all. The balance is incredibly precise. Consider another example: the force that drives the expansion of the universe, known as the cosmological constant. This value is so finely tuned that it has been compared to firing a bullet across the observable universe and hitting a 1-inch target. If this constant were even minutely different, the universe would have either expanded so rapidly that no galaxies could form, or it would have collapsed back on itself long ago. The conditions required for a stable, life-permitting universe depend on this and many other constants being set to their just right values. This remarkable precision is what scientists call the fine-tuning problem. Our own planet, Earth, also seems to be a privileged place. It sits in a Goldilocks zone around our sun, not too hot and not too cold, allowing liquid water to exist on its surface, which is essential for life as we know it. Earth has a large moon that stabilizes its axial tilt, preventing wild climate swings. It has a protective magnetic field that shields us from harmful solar radiation. It has an atmosphere with the right mix of gases for us to breathe. The list of fortunate coincidences goes on and on. While other planets may exist, the combination of so many life-friendly factors in one place seems remarkably fortunate. Proponents of intelligent design look at this cosmic and planetary fine-tuning and see it as powerful evidence. They argue that attributing all of this precision to sheer luck strains credulity. The idea that the universe was somehow designed with life in mind provides a straightforward and logical explanation for why the cosmos is so hospitable to our existence. It suggests that the universe is not just a random accident, but a carefully prepared stage upon which the drama of life can unfold. This perspective transforms our view of the cosmos from a cold, indifferent void to a place that seems purposefully arranged. A common question that arises is, how can we scientifically detect design? Is there a reliable method, or is it just a matter of personal feeling? Well, the method for detecting design is actually something we use in our everyday lives. It's a formal process of reasoning called the inference to the best explanation. We use this logic to distinguish between events that happen by natural law, those that happen by chance, and those that are caused by an intelligent agent. For example, if we see the shape of a face carved into a mountain like Mount Rushmore, we do not attribute it to wind and erosion. We infer design because the pattern is just too specific and complex for natural forces to produce. This same logic can be applied to nature. The criterion for detecting design is the presence of high levels of specified complexity, which we discussed earlier. When we find an object or a system that is both highly improbable, complex, and conforms to an independent functional pattern specified, we can reliably infer that it was designed. The genetic code in DNA is a perfect example. It is not only an incredibly complex sequence of chemicals, but it is also specified because it functions as a language, carrying the instructions to build proteins. This combination of complexity and specification is the key signature of intelligence. This method is not just an argument from ignorance, saying, we don't know how it happened, so it must be designed. Instead, it is an argument based on our knowledge of cause and effect. In our uniform and repeated experience, things like languages, codes, and machines always come from an intelligent source. When we find these same features in the natural world, it is scientifically rigorous to infer that they too had an intelligent source. We are not saying that science will never find a naturalistic explanation. We are saying that, based on the evidence we currently have, design is the most logical and best explanation. Therefore, the detection of design is a fully scientific process. It is based on observation and data. Scientists can test for irreducible complexity by examining biological systems to see if they can function without all their parts. They can measure the information content of DNA and calculate the probability of it arising by chance. They can analyze the fine-tuning of the universe's constants and assess whether it is better explained by chance or design. This is not about giving up on science. It is about expanding science to consider all possible causes, including intelligence, when the evidence warrants it. Despite its reliance on evidence and logical inference, intelligent design is often criticized and labeled as pseudoscience by some in the scientific community. One of the main arguments from critics is that the theory is not testable or falsifiable. Science, they say, must be able to devise experiments that could potentially prove a theory wrong. They claim that because we cannot observe or experiment on the purported designer, intelligent design falls outside the boundaries of science. This critique suggests that invoking a designer is simply a way of stopping scientific inquiry, rather than advancing it. However, supporters of intelligent design respond that the theory is indeed testable and falsifiable. For instance, the claim that the bacterial flagellum is irreducibly complex could be falsified if a scientist were to discover a plausible, detailed, step-by-step evolutionary pathway for its creation. If it could be shown how the flagellum could be built from simpler precursor systems that were themselves functional, the argument for its irreducible complexity would be overturned. Similarly, if a natural law were discovered that could generate large amounts of specified information, the design inference for DNA would be weakened. Another criticism is that intelligent design is inherently religious because it points to a supernatural cause. Critics argue that science can only deal with natural causes and explanations. By proposing an intelligent cause, the theory steps into the realm of metaphysics or theology, not science. This is part of a philosophy called methodological naturalism, which holds that scientists must assume that only natural causes are at play, no matter what the evidence suggests. It is a ground rule that limits the scope of scientific investigation before it even begins. Intelligent design proponents argue that this rule is an artificial restriction on science. They believe science should be about finding the most accurate explanation for the evidence, regardless of whether that explanation is natural or intelligent. If the evidence points compellingly toward a designer, then science should be allowed to follow it. They argue that excluding design as a possibility from the outset is not a neutral scientific position, but a philosophical one. The debate, therefore, is not just about the evidence itself, but about the very definition of science and what kinds of explanations it is allowed to consider. At the heart of the debate between Darwinian evolution and intelligent design are two fundamentally different philosophical starting points. The dominant view in science today is naturalism. This is the idea that nature is all that exists. There is no supernatural realm, no God, and no purpose or design in the universe. From this perspective, all of life and the cosmos must be explained by purely unguided material processes, such as random mutation and natural selection. It is a philosophy that sees the universe as a closed system of physical cause and effect, with no room for a guiding intelligence. This naturalistic viewpoint shapes how evidence is interpreted. When a naturalist encounters a complex biological machine like the bacterial flagellum, they must assume, by definition, that it arose through a step-by-step evolutionary process, even if they cannot yet explain how. The possibility of design is ruled out before the investigation even starts. This means that any gaps in our knowledge are seen as temporary problems that will eventually be solved by a naturalistic explanation. The commitment is to the process itself, with the belief that it is powerful enough to create all the complexity we see in life. In contrast, intelligent design begins with a different assumption, that both natural and intelligent causes are real possibilities. It does not rule out intelligence from the start. Instead, it asks whether we can find positive evidence to distinguish between the two. This approach is based on the idea that intelligence is a real force in the universe. We see its effects all around us in human technology, and it is therefore possible that it also played a role in the origin of life and the universe. This view does not deny that natural processes like mutation and natural selection occur, but it questions whether they have the unlimited creative power that is often attributed to them. This leads to a very different way of looking at the world. Instead of seeing everything as the result of a blind, purposeless process, intelligent design allows for the possibility that some things were made with intention and foresight. It encourages scientists to look for signs of engineering, information, and purpose in the natural world. This philosophical difference is crucial. It is not just about interpreting a few pieces of data. It is about the entire framework we use to understand our existence. It is a choice between a universe of pure chance and a universe that may contain a deeper meaning and purpose. In the end, the theory of intelligent design offers us a profoundly different perspective on our place in the cosmos. It takes us back to that feeling of wonder we experienced under the starry night sky, and suggests that this feeling is not an illusion. It suggests that the order, elegance, and complexity we observe in the universe are not just a happy accident, but are genuine features of a reality that may have been crafted with purpose. It invites us to see the world not as a collection of random events, but as a gallery of masterpieces, each bearing the signature of a brilliant artist. This perspective can change the way we approach science itself. If we believe that biological systems are designed, we might look for their purpose with greater expectation. We might expect to find optimal engineering principles at work in the flight of a bird or the sonar of a dolphin. We might study the so-called junk DNA in our genome not as leftover evolutionary debris, but as a potential treasure trove of undiscovered functional code. This viewpoint fosters a sense of anticipation and discovery, encouraging scientists to search for function and ingenuity in places where they might otherwise have expected to find only randomness and waste. Beyond the laboratory, this idea can also enrich our personal experience of the natural world. When we walk through a forest, we can see more than just a struggle for survival. We can see an interconnected system of breathtaking complexity, a symphony of life where every player, from the tallest tree to the smallest microbe in the soil, has a role. The intricate design of a flower, the coded instructions in a seed, the precise physics that holds the stars in the sky, all of it can be seen as a testament to a vast and creative intelligence. It fills the world with a sense of meaning and wonder. This journey into intelligent design, therefore, is more than just a scientific debate. It is an invitation to look at the universe with fresh eyes and an open mind. It asks us to consider that perhaps we are not here by chance, but are part of a grand and purposeful story. Whether we are gazing at the distant galaxies or peering into the microscopic world of the cell, the theory of intelligent design suggests that we are surrounded by evidence of a mind at work. It is a view that transforms the cosmos from a silent, empty space into a vibrant and meaningful creation, waiting to be explored and understood.